Hello everybody, welcome back to another mathematics video. So, quadratic sequences. This is something new. This is something interesting, hey? It's just more steps to this, but it's not that difficult. So, if we look at the formula, we have Tn is not equal to a plus n minus 1 into d. It's equal to an squared plus bn plus c. Doesn't that look familiar to the fact that we have ax squared plus bx plus c, the quadratic equation? Well, in this case, it's just n. Now, the question is, how do we find all these differences and whatnot? Like, how do we apply this into sequences? Now, notice that n, it's just the nth term. So how do we find the first term? So the first term we find by just plugging 1 into all the n values that we have, and then we'll get something like this. Do you notice that when I plugged in n equals 1, for the first term, right? And then that implied to us that we are going to have a plus b plus c. But what if we plug in the second term, meaning we're going to replace all the n values with 2? And then this is what we're going to get. We are going to have 4a plus 2b plus c. And notice that the c is obviously not going to change because it's literally, there's no n there. But only the b and the a is going to have multiplied by some coefficient. And then obviously for the other one, if we plug in 3, then obviously for the third term, it's just going to be 9a plus 3b plus c. And then for, let's say, a fourth term, we are going to have 16a plus, it should be 4b plus c. Okay. Let's say that we have a sequence with 4 terms, okay? So this is obviously going to be term 1, this is going to be term 2, this is term 3, and this is term 4, using the general formula, okay? Then how are we going to find the difference? Now remember, in order to find the difference, we need to take this value, this second term, and we need to subtract it with each other, which is t2 minus t1. And then to find the difference for this one, we're going to say t3 minus t2. And then we're going to find this difference, and then t4 minus t3. And then what is that going to imply to us? Well, that's just going to imply to us, if we have something like this, usually the diagrams go like this. t2 minus t1 would look as follows. Notice that all I did was I took term 2, and then subtracted by term 1, and then I got 3a plus b. And then obviously for the rest of them, let me just do it immediately for you guys. Okay, so what do you notice? You notice that this is not a constant difference now. Because in arithmetic sequences, these would actually be equal to each other. But unfortunately, because it's a quadratic sequence, the first difference is not the same. So therefore, we don't call it a constant difference or a first constant difference or constant first difference, whatever the heck you want to say. What we call this is just a first difference. Okay, we just call it a first difference. All of that stuff over there. Okay, so I'm going to do all of that. And then obviously this is just the sequence, so it's not really like, there's no technical name for that. But now we need to find the second difference. And remember, to find the second difference, once again, we need to take the subtraction, the difference between these terms. And then this one will just be the term, let's just suppose that this is obviously now term 2 of the first difference is term 1, term 3 of the difference. And then therefore we'll just find the subtraction. But I don't want to write all of that down because it's going to confuse you. So therefore we're just going to go straight into the difference. So if we take the subtraction of each of them, what you notice is going to be 5a plus b minus 3a plus b, which we know that b's are going to cancel. 5a minus 3a, which is equal to 2a. If we look at this one and this one, what we notice, 7a plus b minus 5a plus b, the b's cancel. And we have 7a minus 5a, which is 2a. And what we notice is that it will keep being 2a over and over and over again. And the technical name for this is going to be called the second constant difference. Okay. So it's the second constant difference. The second difference is always constant if it's a quadratic. Okay. So this is basically what we have from all of this information. Now, we've just derived all of the information. Now, we need to know, how do we actually apply all of this information in actual questions? Let's go straight into it. Alrighty, so we are given the following sequence. It's 8, 20, 38, and 62. A says find Tn, which is the nth term, and B says find the 20th term. Okay. So the first step to this whole procedure is to actually use the sequence that we were given. And what did we do with the last one? We just found the differences of each and every single term. We know that term 1 is equal to 8, term 2 is equal to 20, term 3 is equal to 38, and term 4 is equal to 62. So if we want to find the difference, essentially we are just going to do this, something like this. So the difference between 20 and 8 is just going to be equal to 12. The difference between 38 and 20 is going to be 18. The difference between 62 and 38 is just going to be equal to 24. Okay, so this is our first difference, if you remember from the beginning. Now we need to find the second difference. And how do we find the second difference? Exact same procedure that we just did with the first difference. So 18 minus 12 is just going to give us 6. And 24 minus 18 is just going to give us 6. Okay, do you notice that the second difference is staying constant as 6? So adding by 6 every single time. And then obviously the first differences are just adding by 12, then 18, then 24. Okay. So now what do we do from here? We need to consider the fact that we need to find Tn. And we know that Tn, just as a reminder, is equal to an squared plus bn plus c, meaning we need to find out what is our a value, what is our b value, and what is our c value. Okay, now remember, from our proof or our explanation, our a value or our first term is just a plus b plus c. So that is what we are going to do for this one. Do you see the placement of this? Notice that where 8 is, it's in the place of a plus b plus c, right? So that is how we are going to find a plus b plus c. That is the first thing we're going to do. And in the place of 12, that is in the place of 3a plus b. And in the place of 6, that is in the place of 2a. So therefore, in order to find our values, we will let 6 be equal to 2a, 12, so 6 be equal to 2a, then we'll let 12 be equal to 3a plus b, and then 8 be equal to a plus b plus c. So let's first find out what a is equal to. We're obviously going to start from 2a equals 6, sorry. So first things first, 2a is equal to 6, which tells us that a, if we divide both sides by 2, is going to be 3. Okay. And then what's the other one? We're going to let 3a plus b be equal to 12. So 12, or you could say 3a plus b is equal to 12, which obviously tells us that we know what a is equal to. A is equal to 3, so we can substitute 3 in. So 3 multiplied by 3 plus b is equal to 12. We can take 3 times 3 over. We have b is equal to 12 minus 9, which was 3 times 3, which is obviously just going to be b is equal to 12 minus 9, which is equal to 3. Okay? And then in order to find out what the last one is, we let 8 be equal to a plus b plus c. Okay? So here, a plus b plus c is equal to 8. And we know that a is equal to 3, and b is equal to 3 plus c. And then we have 8. So we take this to be 6 plus c is equal to 8, and we take the 6 over, so therefore c is equal to 8 minus 6, where c is just going to be equal to 2. Okay, so since we know that a, b, and c is equal to, then therefore Tn is going to be equal to what? 3n squared, which is in the place of a, plus, remember it's positive and positive, so plus 3n plus 2, where we know that a is equal to 3, b is equal to 3, and c is equal to 2. Okay, so that was obviously how to find the nth term for these types of questions. It will always stay the same for every other type of question. Okay, for number b, we need to find the 20th term. What does that mean? Remember that this is the nth term. So the 20th term is essentially when we replace n with 20. So it's t20, meaning every single n value we see, we replace with 20. So 3 multiplied by 20 squared plus 3 into 20 plus 2. And as cool as I would be if I could just calculate all of this, unfortunately I'm not that smart. But who knows, we can try. Alright guys, so I gave up. The answer, if you put it on your calculator, is going to be 1,262. And I can verify that because I tried it twice. So there was number B. Now, what are we going to do in another type of case where we are just given a scenario? If you remember from arithmetic sequences, we were just given a scenario, then we just need to use a whole bunch of logic to get our answers. Alrighty, so now we are on the next question. So this one says the second term of a quadratic sequence is equal to 1. The third term is -6, and the fifth term is -14. So it's all of a quadratic sequence. So what are we going to do? What do we know? We know that the second term is what? It's 1, right? But what is the first term? We don't actually know. So let's let it be equal to x for now. The second term we know is 1. The third term we know is -6. And then what do we know? The fourth term, we don't know what that is. So let it be equal to y, because we know it's probably not going to be the same as x. So we just let it be equal to another variable. And then the fifth term is just -14. Now what? It says of a quadratic sequence, meaning we're going to have a first difference and a second difference. In order to find the first difference, essentially all we are going to do is we are going to take x and 1, 1 and -6, -6 and y and -14, and we're going to subtract each other with it. So it's 1 minus x. This one is -6 minus 1, which is just going to be equal to -7. Y minus -6, which is just going to be y plus 6. So I'm going to write it a bit better. Y plus 6. And then -14 minus y is just going to be equal to -14 minus y. Okay, we're just finding the differences for each term over here. And now we need to find the second constant difference. And remember, when we're finding the second difference, it's all actually going to be the same value. So what do you notice? This is going to subtract by that, that is going to subtract by that. And what are we going to get? Here we are going to get -7 minus 1 minus x, which is just -8 plus x. It's going to be positive x now. Okay. And then the next one is going to be y plus 6 minus 7 minus 7, so it's plus 7, so therefore it's going to be y plus 13. Obviously I'm going quite fast, but you should be able to do this on a piece of paper if you are too slow with this. And then -14 minus y plus 6 is just going to be -2y minus 20. Should be. Yeah, because of the 6 and the 14. And then the negative goes in. So it's going to be twice for y, and it's negative for that one. It's -20. Yes, okay, cool. So there we go. We got our first difference. So I'll call it first diff. And then we have our second diff. But this is constant. It stays the same. Each and every single one of these variables, or these expressions, sorry, are the same. So take note of that. That means, what is the first question? It says find the second difference. And to find the second difference, we need to know what the value is. So what we'll do, because we know they're equal to each other, we're just going to let this be equal to that to find y. Because if we're going to just let these be equal to each other, then therefore we're just going to have an equation with x and y in it, and we're not going to solve. So therefore, we're going to say negative 2y minus 20 is equal to y plus 13. Okay. And then from here, what we can do, we can just rearrange. Let's take the y over, so we have negative 2y minus y is equal to 13 plus 20 when we take the negative 20 over. And then from here we have negative 3y is equal to positive 33, right? And if we divide both sides by 3, by negative 3, we're going to get negative 11 as our y value. But remember, we saying that y is equal to 11 doesn't tell us what the actual second difference is going to be equal to, if that makes sense. So therefore, what we are saying is we need to plug this y value into either one of these to get our actual second difference. So therefore, this tells us that you can say to get second difference, then sub y equals to negative 11 into, let's sub it into y plus 13. Okay. Such that what we are going to get is we are going to have our second difference. So we can say your second diff is equal to what? Negative 11 plus 13. And that will just give us what? 2. That will give us our value of 2. Alright. So there we go. We just found our second difference. So therefore, you can obviously say now, therefore, second difference, I guess you can say it here because we just stated, therefore second difference is equal to 2. And that is number A. Okay. So here we can just call this A. And then number B is going to be as follows. Number B says, hence, find the first difference. Meaning, we need to find what are these going to be equal to. Okay. So something funny I just realized. I wrote this question wrong. So the actual question was this. Alright, so it wasn't find first difference. I think I wrote this by mistake because of the second difference thing. But it says hence find the first term of the quadratic sequence. I said QS as quadratic sequence. And remember, we don't know what the first term is. So we just need to solve for x. But what do we know about the second difference that we have? We know that the second difference, negative 8 plus x, is the same as all of these. And we know the second difference is actually 2. So therefore, we're going to actually let negative 8 plus x be equal to 2 in this case, right? So that is how we solve for x. We're going to say 2 is equal to negative 8 plus x. Okay, I think that was it. Yeah, negative 8 plus x. So there we go. And now we just solve for x, and then therefore x is just going to be equal to 10 in this case over here. And because we know that the first term is x, then therefore the first term of the quadratic sequence is 10. Or you could even say t1 equals 10 if you want. It really doesn't matter, but just say 10, I suppose, if you want to. So yeah, that is quadratic sequences. Not that bad.